Hi, thank you for joining us for this webinar, Containers and Kubernetes, Visibility through Cloudlens. Your presenters today are Sushil Srivinasan, Senior Product Manager at Ixia, a Keysight business, and Chris Hein, Partner Solutions Architect at Amazon Web Services. Sushil, the floor is all yours.
Thank you, Liz. So clouds are now becoming more popular, and around 93% of all organizations are completely moving into the cloud. And nearly 50% of all the IT spending by 2020 is going to be in the cloud. The initial concern about putting production applications in the cloud has faded as companies now see how cloud service providers can better, faster, and more efficiently maintain an underlying infrastructure and including the system updates and test their configurations. Today, most organizations possess at least some loads of their workloads within their data center, in their private cloud, and some in the private cloud. This means that every organization needs to have a security strategy and architecture that encompasses the cloud computing. When organizations adopt cloud computing, it transitions mostly from on-premise environments where the perimeter of that organization is well defined to an organization that is broader and deeper. Cloud computing virtually expands an enterprise and simultaneously provides more layers for an attacker to target, including hypervisors, development platforms, web server platforms, and web applications. One of the benefits of the cloud is the ability to leverage resources outside of your organization, but that also means that you're dependent on the code that others create to offer. A complex, rapidly changing code base is susceptible to errors and inconsistencies. All these resources are connected together using interfaces that can offer attackers a potential entry point to your network. And when something does go wrong, it's not that easy to find experts you need to diagnose the problem and resolve it. To understand the discouraging state of cloud security, first, the stats from the survey conducted with companies around the globe in 2017 shows that nearly 32 breaches out of 106 targeted attacks. Now, respondents were asked about the incidents in their firms about the targeted attacks and assaults with potential to penetrate the network defenses and damage or extract valuable assets. Now, according to this survey in 2018, the proportion of targeted attacks that were thwarted had risen to 87%. That might sound like a good news, but it becomes clear that companies are sending more and more just to tread the waters. Now, firms are seeing roughly the same number of breaches on an average, and experts believe that the numbers will not fall substantially because attacks are increasing exponentially. Now, the data also reveals uh, a dual reality. On one hand, things haven't changed. Attacks occur constantly and employ many of the same technical approaches that have been used for years. On the other hand, things have changed radically. More attacks take place now than ever before, and they're getting more vicious. We're seeing more assaults on critical infrastructures and veritable assaults of ransomware, which locks users out of their data or technology until they pay up. Despite all the work that has gone into protecting user data and credit card data in recent years, those are not most commonly the nabbed assets. So you can see that the personal information and payment credit card information are the most commonly nabbed assets here. Last year, Ixia surveyed 353 cloud users on their concerns and discovered some interesting things. 82% had increased their use of cloud production for workloads in the past year alone. Of these, 80% were using public cloud production for production environments, and 89% were using the private cloud. In some industries, there may be preference for one or the other, but it seems to indicate that they both are highly relevant in the enterprise today. Security was the number one concern for those using the public cloud at 93% and private cloud at 80%. Regarding the visibility, 60% of cloud users reported having difficulty in getting the visibility to cloud traffic. In fact, 88% of the respondents told us that lack of visibility into their clouds have led to at least one negative result in their businesses, ranging from the delays in application fixes to delays in troubleshooting performances, application outages, delays resolving security alerts, network outages, etc. The fundamental requirement for an effective security architecture is to have a complete visibility into all traffic that enters and leaves and moves through an organization's network. You can protect what you can see, but you can't protect what you cannot see. And this phrase is often what you hear right now. One of the advantages of cloud computing is that the user can set up automatic deployment of new cloud instances when more capacity is needed and automatically retire when demand shrinks. Because this is happening without human intervention, you also need to make sure that visibility to the cloud traffic is also automatic. Today's security architecture will involve a portfolio of threat intelligence, web firewalls, anti-malware, DDoS prevention, security analytic tools, etc. And these solutions need to be provided with the type of data that they need to work efficiently and more effectively. It makes no sense to ask sophisticated, expensive analysis solutions to do the work that can be offloaded to other devices. This is one way to slow down results and sub-optimize the budget resources. Ultimately, your security solutions are designed to provide insight into suspicious behavior that could present a threat or be an element in a multi-stage attack. Which brings us to an importance of why packet data is required in security defenses. Analysis of packet data is the gold standard for security investigators and forensic analysts. It is not enough to know that data came from point A and left at point B. Packet data goes a step further to help analysts understand the specifics of a network session to reveal where a request came from, who are the users who are involved in that particular request, which internal assets were involved, what data was accessed by that particular resource, whether an attack spread laterally through the network or not. Research by Enterprise Management Associates confirmed that packet analysis is the industry's best practice. 51% of all enterprises use packet data today. Another 30% want to do so, totaling of 81% eventually. 35% use deep packet inspection for security analytics and reporting to the tools. Now, it's hard to see traffic when you're looking into the clouds right now. In addition to underestimating their security responsibility, the nature of cloud environments make it hard for organizations to see traffic that is affecting their businesses. Traffic moving to and from between physical resources in an on-premise data center is easy to intercept, and making copies of it is much easier because you have complete access to the network stack. You can use taps or bypass switches to monitor the traffic. Now, traffic moving in between virtual resources within a hypervisor is a little difficult, but you still have access to the infrastructure. So you can have your virtual instances which can capture the traffic at the virtual switch level, and your tools can have access to that particular particular packet data. When you start moving into the cloud, it becomes more and more difficult. And when you start running your application as containers in the cloud, it's highly impossible for you to monitor the packet level data. Next comes Kubernetes. Kubernetes just complicates it even further. In an emerging cloud native landscape, Kubernetes is everywhere. Without a doubt, Kubernetes has become the standard for orchestrating containers. As containers become ubiquitous, managing multiple clusters and running them in a secure way becomes a huge challenge. Let me ask Chris Hine to go through containers and Kubernetes specifics from Amazon.
Thanks, Shishil. So as you've been hearing, there's a lot of industry shifts, and the key ones that we are seeing and have been seeing for the last couple years are really around elasticity. So the ability to scale up and down and pay for what you use. as well as agility, being able to iterate quickly and deploy and fail quickly, going from dev to test to prod extremely quickly, and delivering new experiences in a weekly and daily manner. Right now, this is months and years with thousands of pushes and commits to get to production, as well as highly available software. The ability to auto heal, audit, and manage, as well as health checking, monitoring, and spanning your physical infrastructure across more than one location. Next slide. So enter containers. Containers are a method of virtualization with all of its dependencies in a resource isolated process. There are an application package to distribute everywhere and are infrastructure agnostic and kind of treated as a building block. They give you the benefits of consistency and efficiency, as well as version control using things like tags on images. And we've seen them to help increase cloud adoption and reduce the friction for businesses going through a digital transformation. Next slide. So what does this mean to you? This allows you to deploy features to your customers without waiting on integration dependencies from other teams' code changes. It also gives you the ability to have efficient scaling by taking that individual package and scaling it horizontally. It also allows you to scale only the services that demand more resources, because typically what goes along with a container migration or a container move is using things like microservices to make your application development more streamlined. Next slide. So enter in Kubernetes. Next slide. Kubernetes is an open source container management platform. It's been generally available for about 3 years now. It was originally released in June of 2014 and has absolutely taken the world by storm, especially over the last 12 months. Its rapid gain in, it's also had a rapid gain in traction against AWS customers. So when you strip away the hype, at its core, it's built to help you run containers at scale and comes equipped with features and functions to build proper distributed applications using the 12-factor application pattern. Next slide. And our customers believe there are massive advantages of running Kubernetes on AWS. According to a CNCF survey earlier in 2018, over 50% of Kubernetes workloads run on AWS today. And this was entirely organic growth fueled by a strong community of developers and customers and partners. Next slide. So after hearing from our customers that they didn't want to manage Kubernetes, they didn't want to deal with the control plane or any of the components that go along with creating this orchestration platform to deploy containers on top of, we came out with Amazon EKS, or Elastic Container Service for Kubernetes. Next slide. A little bit about Amazon EKS's architecture. Amazon EKS runs the control plane for customers, meaning that the API server, the cloud controller manager, the scheduler, all the components that make your cluster run efficiently are all handed off to AWS. So we will run all of that along with the distributed state store, etcd, and a customer will go and provision their worker nodes in their account and wrap them in an auto scaling group and be able to scale out those workloads as they need. Next slide. So again, what does this mean for you? When you run Amazon EKS, you get the ability to integrate with the full spectrum of AWS services to help you build microservices and container applications. So services like DynamoDB or RDS for databases, SQS for queues, Kinesis for streaming, CloudFormation for the management of everything, and Elasticsearch to help you analyze things or store data, as well as you get the global footprint of Amazon Web Services. So customers can deploy their container applications in any of the 55 availability zones across 18 geographic regions worldwide, with plans to add around 12 more availability zones and 4 more regions. You also get the security, that Amazon has brought to the table. So Amazon Web Services has achieved a number of internationally recognized certifications and accreditations, enabling customers to achieve their specific security and regulatory objectives. And last but not least, the partner ecosystem. And this is a massive growing community of companies like Keysight and Cloudlens that allow you to deploy applications on top of your containerized environments. Next slide. So within the Kubernetes and EKS ecosystem, there's lots of opportunities for partners. As you can see from this slide, we have the ability to do packet analysis and monitoring using Cloudlens, as you're going to hear a little bit more as I pass this back to Sushil.
Thank you, Chris. So folks, what if you had one visibility platform that can provide packet level data irrespective of where exactly your workloads reside, whether it's in the physical server or whether it's running on a hypervisor in your data center, or whether it's in a hybrid cloud environment which has both public cloud as well as private cloud infrastructures, or if it's running in AWS, or even if it's running within a Dockerized environment, or if it's running in a Kubernetes cluster. One platform which can provide visibility across your physical all the way till anything that's running in a Dockerized container. That's what we have today. From Ixia, we have Cloudlens, which is a platform, a visibility platform catered to provide packet level visibility, whether you're running it in the public cloud infrastructures, whether it's running in a hybrid cloud model, or whether it's running in a private data center. One platform which can provide packet level visibility across the environments. So let's look at the architecture of how exactly Cloudlens is built. Cloudlens has two components which work together to bring packet level visibility in the cloud. The first is a SaaS-based model. This is built completely using cloud native services, and it's built using a serverless architecture, and it runs in the cloud. The second component is a sensor-based application. For Linux-based workloads, we use Docker-based containers, and for Windows-based workloads, we use traditional exe-based agents. The advantage of using a sensor-based approach is it gives us the flexibility to be agnostic to cloud service provider, and it gives us the flexibility to be agnostic to the platform. And all the security controls that have been modeled for a particular workload are inherited by our sensors, which are installed within the specific workload. The advantage of using a SaaS portal is it's much easier to configure. The management is right there in a web portal, and everything is easy to access as long as you have an internet access. And using a SaaS-based approach gives us the flexibility to scale elastically. Now let's take a look at how this works. Now you have your production instances which have traffic which are going out into the network, and you're interested in sending the traffic to the tools that need this packet data for further analysis of those particular information. What we do is we install Cloudlens sensors within your workloads, within your application that you're interested in monitoring, which we call the source, and where you want to eventually send the traffic to, that we call the tools. So once we install the Cloudlens sensors within the source and the tool instances, we get access to rich metadata information about the source and the tools, and that information is forwarded to our SaaS portal. Based on that information, based on the metadata, as a user, you get to create filters right in the source and forward traffic directly to the tools that need the information, need the packet level data. And you send only the relevant data to the relevant tools. You eliminate all the unwanted data right in the source itself, and you forward the traffic through our secure peer-to-peer VPN tunnel, which gets created. And the tunnel basically originates in our source sensors and terminates in the tool sensor. So this is how Cloudlens works. Let's go a little deeper in how this environment is set up. So here on the left, you see the source workloads, which are divided based on their metadata information or grouped together based on their metadata information. I have my 3-tier architecture, my app, web, and database groups. On the right side, I have all the tools that are interested in monitoring this information. On the right side, I have my security, APM, and health check groups. With a simple drag and drop, we create this peer-to-peer VPN tunnel, which goes from my source instance to my tool instance. Now, the advantage with this is as and when your workloads scale up, as long as they have the same characteristics, they automatically get added to the group which has been defined for them. And the new workloads which spin up automatically inherit the policies that have been defined for that specific group. What you see here is the existing architecture, customer's architecture. There are no additional infrastructure costs associated with this particular solution. We don't add any additional EC2 instances. We don't make any changes to your architecture. We bring in visibility using your architecture, using your infrastructure to the tools that need this particular packet data. Now let's go a little deeper into how specific use cases of how Cloudlens can be used for container level visibility. Now, in this example here, I have a Jenkins container and an Nginx container, and I have traffic which is going on between my Jenkins and my Nginx containers. This traffic never leaves the host. For you to monitor this traffic, Cloudlens can be used as a solution. Cloudlens acts as a container, monitors the namespace of the container that is of interest, captures the packet data, and forwards it to tools that need the traffic to be visualized. Now let's take a look at how this solution can be easily used in a Kubernetes cluster. So you have a Kubernetes cluster defined, and the way Cloudlens operates is Cloudlens sits as a sidecar container within the pod definitions within your cluster. And any traffic going in and out of that particular pod, a copy of that is got by Cloudlens containers, and that can be forwarded to your traditional tools that can visualize this particular data. So whether your data runs in your physical servers or whether it's running in a Kubernetes cluster, the same platform can be used everywhere. With that, let me go through a short demo of how Cloudlens works in Amazon's EKS environment, as well as Amazon's COPS environment, which is a precursor to what was available before EKS was supported. So this is a recorded demo, and let me go through the short demo here. So here, what I've done is I have created three separate CloudFormation stacks. The first stack is actually the control plane EKS stack. So that has defined security group. It has a VPC defined and it has three separate subnets. The next one is actually an EKS worker node. So I have three separate worker nodes defined here and an auto-scaling group defined, specific AMI associated with this particular cluster. And these are all the different subnets that have been created and the VPC. Now let's take a look at the Cloudlens setup that we have. What I have here is the project key, which I pass as a parameter to my CloudFormation template. The project key is part of definition within Cloudlens on how this workload needs to associate with the project with our Cloudlens SaaS portal. This is the setup that you see here. In this setup, I have my traffic source as an XA developer as my traffic source, and I have Moloch, which is running in a COPS environment, and Circada, which is running in the EKS environment. So here on the left, I have my XA developer. I have the project key on the right-hand corner there, and I have three separate tools which are receiving the traffic. I have Moloch, Circada, and NTOP. We're going to be focusing on Moloch and Circada today. And I'm going to be sending traffic from my XA developer to these specific tools. What you see here right now is the COPS environment of Moloch. And within that particular service, I have access to Moloch infrastructure. And what you can see are the packet information that's being received by Moloch from my XA developer. And this is the Circada instance that you can see. And within Circada, there have been specific strikes, there have been specific packets which have already been associated with this. So you can see different protocols, you can see different ports associated with it. And you can also see the different TCP and UDP, the protocol types that are associated with this particular example. So this is our traffic generating tool. What I'm going to do here is I'm going to delete the existing one that I have and create a security traffic profile where I'm going to generate multiple strikes, multiple browser exploits and miscellaneous exploits between my client and server entity, which is running within my XCA developer. And I'm going to forward that using Cloudlens to the tools. So let's take a look at the setup here. So I have two Helm charts. One is my Moloch on the left side that's running on the COPS environment. And I also have the NTOP environment, which is running in the Kubernetes service. So also let's take a look at the different nodes that are associated with it. Here you can see the specific worker nodes associated in the EKS environment. On the left side, you can see all the nodes associated with the COPS environment, and you can see one master and two separate nodes associated with the Kubernetes cluster. So now my traffic is being generated. Let's go into Circada and take a look at the traffic that's being generated here. So here we go. This is Moloch. So these are the different sessions, which let's refresh it once. We can see the different sessions that are associated here. This is the packet level data that's being forwarded through Cloudlens from the client and server entities running in XCA developer. So you can see that these are the two connections. One is my client entity's IP address and the other one is my server entity's IP address. I have traffic being forwarded between the client and server entities, and a copy of that is being forwarded to Moloch here right now. So you can see that traffic being received by Moloch and Circada. Now let's go into Circada and see the different hits that we have been created. So right now we have around 40 different hits that have been recorded. So these are all the different source port hits that have occurred. And you can see the different events over a period of time. So far, you can see that there are 35 counts. Let's just refresh it once, and you should see a change there. So you can see the different alert counts increase from 35 to 41, and those are all the different alerts there: SSH, SFTP, HTTP, etc. So as you can see, we are able to distribute the traffic that's coming in from XCA developer. The same set of traffic can be sent across to three different tools right now. And that's the setup that we're talking about, where we have XCA developer forwarding traffic to both Circada and Moloch. So let's take a look at the benefits of cloud visibility. So how can an organization get access to these detailed packet level data, right? So on the left side of this picture, what you can see is your different source environments which are running in the cloud. And on the right side, you can see all the different tools where you eventually want to monitor and eventually want to send the traffic to. Now, using Cloudlens, a cloud visibility platform, which uses a container-based approach, which is embedded in each one of your workloads, we can provide visibility not just from an instance-based solution or from a virtual appliance-based solution. We can bring visibility into a container-based environment, or even if it's a Kubernetes cluster-based environment, we can continue to bring visibility with ease. The major benefits of Cloudlens are basically it's a distributed environment. It uses a cloud native solution, and it's agnostic to any cloud service provider where your workloads reside. And it can operate across cloud service providers, not just within your private data center to the public cloud. It can operate across clouds as well, across cloud service providers as well. It's built on a serverless architecture, and it's very easy to implement. And you can filter data right in the source and send only required data to your required tools that need that particular data. And it has a cloud-based management interface, and it can be accessed from anywhere as long as you have an internet access. With that, let's just go through a short recap of what we saw in today's webinar. we saw how easy it was using Cloudlens to bring visibility in any infrastructure. And we saw that this infrastructure can scale up and scale down, primarily to address cloud scale. It's very simple, very easy to use. It's a drag and drop. We use the drag and drop approach. And because everything can be is automated through Cloudlens, it's much easier and it definitely reduces a lot of errors. And you are with Cloudlens, you can forward your packets securely from any source to any tool. With that, I'll pause for any questions.
Hi, Sushil. Chris, thank you so much for all that info. We did have a few questions come in the back end. I want to remind the audience that if you do have any questions at this time, please put them in the chat and we will get those. So the first question that came in is, how do I deploy Cloudlens on my EKS cluster?
So the way Cloudlens operates is it works as a sidecar container within the pod definition. So when you're defining your pods in your Kubernetes cluster, Cloudlens containers are defined within the pod definition. So it's very easy for us to integrate, and anything going in and out of that pod can be very easily visualized by our Cloudlens sensors.
Okay, thank you. Next question. Does Cloudlens run on Amazon EC? Oh, excuse me. This one asked to be deleted by the user. So the next question is, can I run any instance type with Cloudlens?
Yes. So Cloudlens is basically Cloudlens sensors are not dependent on the type of instance or not dependent on the platform it runs. It can run in Linux-based instances. It can run in Windows-based instances. For Linux-based instances, it can run in any type of instance type. We can run on a T2 micro, or it could run on a C4 8x large instance for that matter. So the sensors are installed within the workloads, and it's very easy for us to dynamically move across environments.
Thank you. And then again, audience, if you have any questions, please put them in the chat. We have one last one that just came through. So if we don't hear from anyone else, the webinar will come to a close soon. The last question that came in is, how does this compare to Amazon VPC flow logs?
That's a good question. So log data and metadata, which cloud service providers, including Amazon, they provide that information. But log data and metadata information are not actionable information, are not actionable enough. So for deeper insight of what's going on within a conversation that's happening between two instances, you need to have packet level data access. So what basically log data and packet data can provide is, like, probably when there is two instances conversing with each other, you can get information about when the conversation started, what type of conversation it is. But the actual intent of the conversation, is there any malicious content within that conversation? That information is not available with log data. Packet data can provide you that level of granular information. So that's a significant difference between what VPC flow logs or CloudWatch, CloudTrail logs can offer you and what packet data can offer you.
Great, thank you. I don't see any more questions coming in at this time, but I want to let the audience know that if any other questions come up, please contact us at ixiacom.com/contact/info, and we'd be happy to connect you with the right people to get your questions answered. Sushil, Chris, thank you again so much for all this information. This recording will be out in the on-demand world, so we'll be sharing it far and wide. And audience members, if you want to share this with anyone, please share this link with your colleagues. Thank you.